Okay, so let's go through this example here and follow along the best that you can. I don't think this isn't the easiest thing. I'll try and explain it the best that I can. This is where, these are, this is an honors type problem. So it says a restaurant gives a free fortune cookie to every guest. The restaurant claims there are 500 different messages hidden inside the fortune cookies. What is the probability that a group of 5 people receive at least 2 fortune cookies with the same message inside? So basically what this problem is saying is they have 500 different messages, but that doesn't mean that the messages won't repeat in some of the cookies. So we've got a couple of different things that we need to do here. So because we have 500 possible messages, if you recall back to the very first thing that we did in this chapter, it was the counting principle. So if I'm taking 5 people and they have 500 possible messages to start, then that counting principle says 500 times 500 times 500, okay, and you keep going 5 times. So the same thing as saying 500 to the 5th power. So that is the number, that's the different number of ways to give messages to the 5 people. Okay, that's what the first sentence of the solution is. The number of ways to give messages to the 5 people is 500 to the 5th power. Now, what we also have to look at is the number of ways to give different messages to the 5 people, assuming that they all get different messages. So that one is our counting principle where we'd say 500. Well, now there's no repeat, so it's 499, then 498, etc. And that's what you see here, 500 times 499, 498, 497, 496. So it says the probability that at least 2 of the 5 people have the same message is. So now here is what's important. It says at least 2 people are the same. In other words, we have messages that match. That is equal to 1 minus the probability that none are the same. So that's what is more difficult about this problem, is that we're not necessarily going to be able to find the probability that at least 2 are the same, but we can figure out the converse of that. Is what's the probability that none of them are the same? And if none of them are the same, we can subtract that from 1, and that will give us the probability that we get 2 or more matching. Okay, so we can figure out how none are the same simply by doing this. We take this portion, assuming the number of ways where they're not the same, and we divide it by the total number if they are the same. Okay, so this is the total ways that the 5 people can get messages, and this is the total ways, this one is the total ways they can get 5 different messages. So if you divide those, the 500 times 499 all the way to 496, divided by 500 to the 5th power, this is what you get. Now if you change that to a percentage, that would be 1.99%. So you have a 1.99% chance of 2 of the 5 people getting the same message. Okay, so what I want you to do is do this one on your own. Set it up exactly like you would this one. This is an interesting problem. It says there's 10 people at a dinner party. What is the probability that at least 2 people have the same birthday? So set it up the same way you did this one, okay, and see what you get. And then hit play when you're ready. All right, so hopefully you were able to get this, but here's the idea. So the number of ways for different birthdays, that means that if we went to the 10 people, it would be 365 times 364 times 363 all the way to 356. That would be 10 different birthdays because you can't repeat. The number of ways for birthdays in general, when we choose them, is going to be 365 to the 10th power. So then we do the number of ways for different birthdays divided by the number of ways of just the way that we would pick birthdays in general, and we get 0.883. Well, again, we're going to do this the same way. So this is the probability that none are the same. Different birthdays over the total possibilities, that's this probability. So we do 1 minus that, 1 minus the 0.883, and we get 11.7%, or we get 0.117. That actually may be a surprise to some of you. Can you imagine what it would be if we had 30 people in a class? You might be surprised at what the percentage chances of people having the same birthday. It's a lot higher than what you think. So hopefully that made sense. Make sure that we can discuss this more in class if you want. So bring questions to class, and don't forget to take your quiz.